Got it.
Okay, so welcome to the Offensive Golang Red Team Staff Talk. I'm Fran, as known as Mr. Tux. You can find me in GitHub or LinkedIn as Mr. Tux. I'm a senior offensive security engineer in Oracle, and I'm from Canary Island.
And myself is Gerardo. I'm from Albacete. Maybe most of you doesn't know nothing about that. It's in Spain. And I'm currently a senior red team operator at Zurich. I do pen tests, I break things, I develop malware. I have a blog and a couple of certs.
So the first question that we want to answer here is that why this talk? It's because we identify the following problems, okay? The first one is creating offensive security tools like OECT take too much time. And I would like to have the basics. For example, template. This is the second one, lack of template for building your own ACT. Then we would like to have something modular, because in the same repository, we would like to use different techniques for evasion or for injection. And the last one, we would like to reuse code, another piece of code in Golang or C. So why in Golang? There are a lot of advantages of using Golang. These are the common ones, and everyone that uses Golang say the same. Is cross-platform, cross-compiler. That means that you can run and build this binary in every environment. You can use coroutines. Sometimes it's very useful. CGO. That means that you can add C code in your own code. Then there are multiple third-party package libraries that you can use in your own code. Sometimes it can be quite difficult for malware analysts, but maybe they don't think the same. These are disadvantages of using Golang. We have heavy binaries, and not all the information is obfuscable. For example, if you build a DLL and you want to export a method, this method cannot be obfuscable. And the last one is that certain low-level limitation that you don't have in C. For example, if you want to try to exploit DLL injection with a Golang DLL, you cannot take advantage of the DLL main by default. But in the with a C DLL, you can do it. So what is the goal of this project? 2 years ago, I started this project because I was inspired in the Michael Long and Ben Kurth. They provide some piece of code that where they are explaining how to create a simple reverse shell or simple evasion techniques. So I think maybe we can create a collection of offensive Go packages as a starting point to create your malware. So this is the repository. This is offensive Golang. It's a suite of different modules to develop offensive tool. Okay, here you have the URL and you can access. So what is the structure? The main part of the repository is the package part. Here we have the principal code. If you want to add a new technique in evasion or injection technique, you have to add it here. For example, we have a different evasion technique for AMSI bypass, for detection the sandbox, least processed, echo, also the exfiltration. We can exfiltration by teams. And then we have a different techniques of injection, fibers, create thread, and everything. So when you develop your own code, you only need to import the package that you want to use. This is modular way because in your own code, you can use different techniques for evasion or injection. And here, we have the example of use. We have different examples of DLL and portable executables. If you analyze this code, you can see how import the package of the injection that we want to use. Here is the most interesting part if you want to use our code, because it's functional and you only need to add the shellcode or the different technique. But this is a starting point, because it's the basics. So how to use it? First one, install the repository and the requirements. If you use Linux, you need to install these dependencies, and if you use Windows, probably you have to do more steps, but it's easy. Then it's recommended encrypt the shellcode and the key elements. So here we will provide two examples. The first is the simple example. We can call to the get encryption method in the encryption package and only put the shellcode. Then if we run this code, we obtain the encrypted payload, the encrypted key, and the file with the encrypted payload. And the second one is more complex, but we wanted to simulate our APT. For example, we can put an URL in the top, it's a Spanish newspaper, and a pattern. And then we can call to the extract map stream from URL method. And this will make a HTTP request and extract a password with this pattern. Then with this password, we will encrypt the shellcode with the method get encryption with password. And finally, we can encode with Brainfuck coder the URL and the pattern. So if we run this code, we obtain the extracted password, in this case is Guerra de Rusia and Ukraine, encrypted payload, encrypted key, and the Brainfuck code for the URL and the pattern. Okay, so we have the basic for initial or malware. And now we have to choose the technique and import the module. In this case, we will use Fiverr's technique. We learned this technique in the MalDev Academy. And this is the version 1. Gerardo will explain the version 2 because we added more improvement. Basically, Fiverr uses units as application in Windows, not threat. So at the beginning, we can see how we can import evasion module for check the name. If the binary don't match with this name, the malware don't run in the victim machine. Then the check mouse. This will wait in 5 seconds until the user move the mouse. If the user don't move the mouse, the malware don't be run. And finally, check the screen. If the screen is very small, that don't run because probably it's a sandbox or a virtual machine. But this is a standard parameter, so you can change this in the code too. Then we put the encrypted shellcode, the Brainfuck code for the URL and the pattern. We decrypt the shellcode in memory, and we run the Fiverr version 1, importing the module. And the second one is for build a malicious DLL to bypass AMSI. It's very simple because we create the structure of a normal DLL in Golang, and we import the AMSI bypass module in the evasion package with the process that we want to bypass AMSI, in this case PowerShell. Okay, so the next step is build the binaries. In this case, you can build this with Garbel or normal Golang, but here we use the native Go. This is for the binary.exe, and the last one is for the DLL. Okay. So now I will show you a simple demo. The first one is the AMSI bypass. The details is that we are running a DLL via run DLL 32. We try to bypass the AMSI. In the victim, in the computer, is running the CrowdStrike Falcon sensor and McAfee's antivirus. So, oh, fuck. Now, if we put invoke Mimicat, we can see that the antivirus killed the process. CrowdStrike put a notification, an alert. So now we can download the malicious DLL, and then we run the DLL with run DLL 32. And we call the export method, in this case bypass. And if we run, and now we run invoke Mimicat, it's not a malicious process. It's not recognized because we haven't loaded a Mimicat, but nothing happened. And if you scan with CrowdStrike, say this is a serious suspicious file. So we bypass AMSI correctly, so it's fine. The second one is a simple demo with the fiber technique. In this case, we will use a shellcode encryption, brainfuck encoding for the URL and the pattern, execution delayed until the mouse is movement, and injection using fibers. The computer is the same with CrowdStrike Falcon, McAfee's antivirus, and in this case, we will try to set up a shell using a meterpreter. In the left, you can see how it's running CrowdStrike and McAfee. Now this is the agent, the CrowdStrike is running. So here is the Metasploit listener, and in the right, we download the malicious binary. So when we run this binary, we'll check the name, the screen, and we're waiting 5 seconds until the user moves the mouse. Then when the user moves, the injection is executed, and now we run the basic command. We spawn a shell with meterpreter. They have a very bad offset, and then we spawn another PowerShell. So now with the session active, if we scan this binary with CrowdStrike, it's not a suspicious file, and we have the session active. So that is the first part.
Thanks, Fran. And right now, with this kind of box that you just see, you will see, OK, is that pretty easy to do only a meterpreter or an AMSI or whatever. But let's try to do more Boolean to the CrowdStrike guys. Sorry if there is anyone here. So the good part of that is not only to see a GitHub, is to try it, to play with it, to enjoy using it. Here is why myself, as a red teamer, and Fran, that we are in separate companies, get together. Because I use that in order to perform an offensive security toolset that is our day-to-day as a red teamer, pen tester, whatever. So what happens with EDRs and Golang? Mainly, you will see something that is currently detected because 1C2, and maybe you know about that, is a sliver. A sliver is pretty used. Cyber attacks currently goes pretty savage there, and it has everything. Now it's Havoc, is what usually happens. But there is something interesting with Golang that you can see here that is perfect to backdoor some packages, because Golang doesn't go directly to the main. It starts in another way. So at the end, you can have 3 different packages, and it's not going to execute the main first. It's going to execute the init function. So if you, for example, have a sandbox, you can put some detections of sandbox in the init and your real payload in the main. It's pretty freak, but it's interesting to try it out and play with it. So as a malware developers, we are starting playing. And what usually happens, we are pretty skilled, we know how to hack things, we do almost all the modules of Maldev Academy, but it's an unknown executable, and we are using maybe the most detected Windows API that you can use, but usually it works. So why to use in 2024 this kind of injections? Or who is doing that? The bad and the really true about that is in 2024, the good malware developers are hiding that code, but this code is always there. It's as easy as go to breach forums and go what are the anti-cheat bypass are using them, and you can apply, maybe something works. So let's try again. We see Fibers one, it bypassed CrowdStrike, but let's go one step further. And this is the good part, and this is for you, like a quick map of what it changes. Basically, it's the APIs that we use, and that's the OPSEC benefits that you can still perform doing that. So there is a demo about that, because the good part of execute fibers between a thread is that there is one cool way to execute things without using threads, because you can use an API of Windows that is switch thread to fibers, and from that fiber you can execute fibers without creating any new thread. Could be interesting, and in that part we use something that are pretty good. You need always to remember that machine learning via sensor is going to be there, so keep calm and try to not break things. And I just speak with Fran, and I say, should I do all the demos in live? And say, you are crazy. If we have time, I will do that in live too, but we can see it. Give it a play. So what is that, mainly? We have at the right, okay, CrowdStrike running with the Microsoft Defender antivirus. We just copy the fibers, give the time to analyze, and execute through a PowerShell. There is something strange there, and maybe, shit, we have a beacon. That's not pretty good. And of CrowdStrike, something happens. It's rare. So let's see what is going up. Yep. So let's try with another technique. We have fibers. We can execute things. We can bypass. We know it for the first version 1. So we tried to play a little bit in the version 2. So let's try it with something that is more similar. It's not new. In Maldev Academy, have many years. It's Process Halloween. So we want to demonstrate this kind of injection of a real C2 of CrowdStrike that is known for almost everyone. If you don't know it, you need to go back to the first course of hacking. But what we trying to do, looking into the process hierarchy that we see in Windows, and we observe that that's only based in our experience. Maybe it can differ if you work with an EDR product under all the stuff. You maybe differ with us. But we observe that the process hierarchy is pretty important in order to get a detection or something malicious. So we will try to use Notepad. Who that makes malware use Notepad? No one, no? Or yes? So let's try a step by step. That's not going to read all of that for you. That's if you want to look at the slides after the talk and speak with us. We are free. We are Spaniards. We love beer. And let's see what we can do. We are going to try to use some Win APIs that are known by everyone. We are going to copy a shellcode into a mapped one, but what if instead of cipher this shellcode, we don't cipher it? CrowdStrike may see it or not may see it. Let's see. So there is some OPSEC benefit about using that. And this time I say to Fran, no, I'm not going to show a video. I need to show this in live. So we are playing with fire, guys. I take it here. Let's see what we have. Let's see what we don't have. It's not internet. So we have a problem right now. Let's try it, because my internet disconnects. It's a Spaniard, and he loves it. Let's see. If not, I'm going to show you at the end. I have a video, but I want to perform it at least for you. So let's follow with the video, because this shit disconnects. And I will show you at the end. But what will happen, or not, or what not, right now when we have internet? So we have the Halloween DefCamp. We copy into our box. And once we going to execute it, what will happen? We use one cool technique that Fran develops. That is the move the mouse in order to bypass any kind of protection. But there's a new beacon. The process is not bad. Something strange happens. But I will try to show you at the end. OK, don't worry about that once we have internet. So let's continue playing. We have loaders. Let's continue with our OST, because our OST is not only use loaders and inject shellcodes and have C2 connections. We need tools. OK, let's talk about exfiltration. Any one of you knows webhooks of Teams or play with that? That's my guess. So that allows you, if you want to create a bot, or if you want to create something, to interact with Teams. You can create a channel. You can have a webhook, put it, and it will do something. But what if we combine that using an antivirus and CrowdStrike? Let's see it. So we have here, that's like a pretty good dog, as you can see. That is the DefCamp. And we are going to execute our thing. Oops. We have a new keylogger callback. But OK, that you can do with whatever. I need to show you something fine. So let's write Notepad. Oops, we have Notepad there. Strange. And what if we create the super duper secret password? What it happens? Oops, is that my password? But if we write hello DefCamp, what will happen? Let's see. Oops. So there is something interesting. And what is the date? Is this morning? Maybe? Interesting, no? To see that. So I'm taking some of the ideas that we have. Fran and myself say, why we don't develop a reverse shell? No one in cybersecurity do that. No one creates a reverse shell. There's like 5,000 results, but we need to try it. So let's try again to go one step further. Why not use Echo? Because most CDRs, day-to-day, love to do memory scan. They use Moneta, they use other kind of products to scan the entire memory during an execution of a process and see if there is any string, if there is any IOC, if there is something that they can use. So what we say, let's go to create one using a spider. So this is what you have in offensive Golang. It's called Echo. It's not our technique. It's created by a guy that is fucking amazing. That is a spider. He have 19 years old, I think. And he created one cool way to encrypt memory and do a sleep meanwhile in order to bypass these kind of things. So let's try to see what happens when we have a DefCamp. We run our incredible super reverse shell. And let's play with that. CrowdStrike is there. He's taking his time of his life, enjoying. So who am I? Oops, we have our user, but maybe that's not something malicious. Let's try with a task list in order to see all the process running. It takes some time because it's encrypting the memory, deciphering it, and we have, as you can see, our client DefCamp running in the process 8,100. So before move again to the demo, because I need to do it, okay? Let's talk about detection response and give you a ton of ideas, okay? If you are working with malware or not, or you want to start, let's say, some points, okay? So mainly in our experience, again, this can differ a lot of the reality, that maybe someone here works as a detection engineer and can say, no, that's not the way that we do. We have common APIs that are monitored. You can see it with tons of tools right today. They have an example of them. So you need to take care in order to what you want to use and what you don't want to use it. And what happens too about the process and the threat origin. You need to take care always about that. So that's how CrowdStrike works. For example, Microsoft for Endpoint have his own way. They have a ton of information from GitHub, from your PC, from the PC of your neighbor. They have a ton of GitHub. They can see if there is unique hash for that exe, if it's in your computer or is in others' computer, and that's an incredible way of detect it. But mainly what we observe, because this is always working with the computer capacity of your PC, is that you have a process and threat origin always, and a parent-child process hierarchy, that you need to focus into that and be very cautious. So, okay, let's try to use some other ideas. They have, as I told you, the memory's origin. They do an incredible job doing a code stack inspection for suspicious linking, and they do real memory scanning. Again, you need to be very cautious with that, because that's what is going to happen. So how, as a malware developers, can try to play with that bypasses? Because as hackers, we know that our final goal is have time, and this is the game of the dog and the cat. We, as a red teamers, are the dog, and the guys are the cat. So if they can catch it, it's okay. If not, we get it. So that's some ideas that we observe. We play with that. You can encrypt or obfuscate memory allocations. That's the same as echo. You can use direct system calls or indirect ones, or have another kind of things. And for me, my favorite is, if you don't know, or if you need ideas of how to bypass these new incredible multimillionaire brands, go to non-cheats. These fucking guys are amazing. You go crazy with the techniques that they have to bypass the anti-cheats. So maybe the anti-cheats are superior to EDRs. We don't know, but let's go to the demo. Let's go to try it and see it. And for review that, this is the configuration that we have into our CrowdStrike. If anyone wants to play with that, is the phase 3 of CrowdStrike. I think it's almost the most advanced of it, and you have some of it. The slides is going to be online, so don't worry about it. If you don't see it, you can ping us, Fran or myself, and that. So I'm going to do the demo, Fran, in a minute.
Yes, sure.
You can tell them a joke or something. So let's try to put a moment. Sorry, guys. I need to put credentials. It's not because of me. So let's see. Let's see if my IP changed or not. Please No, don't change. And it looks like it's not changing. Okay, so hey, I'm doing. Quit my screen a moment, please. That I need to put some credentials, and these people is going to hack me. So let's open this here for a moment, and let's set up in a bit our Cobalt Strike.
But now I can see his password.
Oh no, you are seeing the super duper password. This is his password 123. Who don't use that? Come on, connect. Okay, it's reconnecting. You can put it if you want right now. Perfect. So there we have our Cobalt Strike. It's going to pop up that I don't have the money to renew it. Sorry, guys. Red Team Life. We don't earn too much. We do too much. Please, works. Come on, it's loading everything. Hey. You got it. So let's see. Okay. As I told you, I tried this yesterday and this morning, but I said, these people want to see on live because at the end I can say things and you need to see it, okay? So let's start with the Halloween one that we have here. I'm going to copy it, if I could. Copy and paste it. So it should be detected by our incredible CrowdStrike that is there looking into us. So let's see what happens. With that, this is the technique that I just told you about Fran. That is amazing, and it works flawless. What? What's that? I think we have a problem, Fran. But you will say, okay, that's one, but what about fibers? It's not the same. Let's try fibers. We have time. We could do these kind of things. So there we have fibers. And fibers, once I execute it, oops, have another beacon. You can see them. I pay for the license, okay? don't worry about that. And what about the code? We talk about one reverse shell. We talk about some things, okay? So this is mainly some code of it that you can request if you need the reverse shell that we use for do this kind of things and try to have it for your pen test or whatever. You can try to use it. We use the port 80. What are you looking? Where try to look in my IP, guys. That's fat. The same with the keylogger. We can send to you if you need it. And you will say, okay, what's fibers 2? That is ton of code. And Halloween. The funny part is that these two codes that I'm actually executing were part of our red team operation. Okay, so that works. That's live. That's 3 months after the red team exercise. It still looks like it's still going. So I don't know if that's pretty good or not. So, well, here we can execute whatever we want from our OST or whatever. And that's something that we would like to show you. And the first part, yes. And the best one is how to play with the code. Again.
Awesome. All right. Thank you so much, guys. Do we have any questions from the audience? Yep, we have one right here.
Oh, no. One guy of CrowdStrike. Run.
Thank you, guys, for this incredible demo.
You're welcome.
I want to ask you something. For example, now you've shown that you can get a reverse shell. Is it possible to run something more malicious than just a keylogger like Mimikatz or dump Elsa's credentials or something, and even then it won't detect you.
Let's try it. Why not?
Let's try.
So let's try and start with this one. So I think I don't remember exactly the command. So the best is to use that. Let's try a screenshot that is pretty used for us. So we can try it. I'm going to call it DefCamp. The name is PMP. And let's try one. And let's see once we have the thing running, we can see it. But mainly, yeah, I use that for SOCs. I use that for not by dump Elsas like that from a beacon, because I'm not crazy. I don't want to lose my beacon. And what do you usually do when you want to use Elsas? And that's a trick, please. Don't burn me. I'm seeing all of you. Dump Elsas with this kind of products. Use their own products. If you want to, for example, and the best way to do it is use Magneto. That is one tool of DefEar. Take notes. Yes. That is one tool of DefEar in order to dump the entire memory. It's too big to dump, but because you are dumping a lot of data, it's not, for example, as suspicious as go directly, open a direct handle to Elsas, and get it. But yeah, you can use that freely in your operations. The main thing is you need to play with more things, not only this one. Fran, as you can see, can use Meterpreter and get a shell. So when you get the shell command in Meterpreter, you are loading a DLL.
Yep.
Yes.
And you can run incognito and everything, and it won't break the beacon from MSF console, from Metasploit.
Sorry? Can you?
If you run the modules from Metasploit, the incognito module, for example, it won't break the beacon.
You need to try it. We can say anything, but CrowdStrike have his own things, okay?
Because a lot of times I've seen getting back reverse shell, but as soon as I try to run something a little bit malicious, everything drops dead.
Of course, if I execute here in CrowdStrike a shell, who am I? It's going to be born, because the memory scan is looking always for EOCs or Yara rules. They have a ton of them. CrowdStrike is a pretty old product. The same with Meterpreter. They are old. They are 20 years almost. So it's very known for not only the good people, but for the bad people too. So if we want to have these countermeasures from the defender side, they have all the tools. The CrowdStrike code was leaked. The Meterpreter is open source. The Sliver one is open source. They have all the things, and you need to play it. That's the good part of the job as a red team operator, that you cannot play and get everything hacked. You need to understand the way to move it and to go around all the detections. But there is ways, always.
Thank you very much.
Awesome. Awesome. Thank you so much. So we have another question over there in the middle. Yep.
Hello, great presentation, but I wanted to ask, so you mentioned that at one point you used brainfuck, and I wanted to ask, given how old it is, why did you choose to use it, and how come it's not detected in one way or another due to its age?
Sorry, can you repeat? Sorry.
So, can you go a little bit into your choice as to why you employed brainfuck for, if I'm not mistaken, obfuscation,
Okay.
given its age?
It's only because we wanted to emulate an APT. So, but when you, in theory, when you are analyzing the code, we try to put more difficult to malware analysts, and for that reason we put the brainfuck code. But it's not. This part is not a bypass of EDR or something like that. This is irrelevant. The best part to bypass the EDR is the fiber techniques, how we implement that. The other techniques is only for evasion that a static analyst or sandbox or something like that, but no for the EDR.
Okay, thank you.
The short answer is to laugh about the SOC that are very bad, and we can laugh in that way. But yeah, mainly the brainfuck, as you say, is pretty old. It needs to be malicious or something suspicious at least, but you need to see that it's going to be a ton of them. We use that to show how easy you can do some of these kind of things with Golang. But instead of use, for example, brainfuck, you can use the name of Pokemons. You can use English words, because at least what an EDR is going to see, and if you go deep in the machine learning detections, is going to be the entropy. Lower the entropy, better results, always. So yeah, that's an example. It's pretty good.
Yes, and they're the basics.
All right, awesome. Thank you so much. There's another question over here up front.
Hello, and thank you for the presentation. I was wondering if you could steal user account control passwords while not being detected.
Excuse me? Can you repeat it again?
If you can steal with Golang and your library user account control passwords from Windows. You know, when you log in as administrator.
Sorry, but the sound is not. Give me a moment.
Yeah, because we...
Go there. We cannot hear you. Man, tell us.
If you can steal user account control passwords from when you log in as an admin, you can steal that and get it to a random server later.
Still the password of the user when we have the session.
Yes.
Yeah, we can do it, but that is depend of the. So for everyone that don't listen to the question, if I'm not mistaken, he is asking us if we can steal the password of the, for example, the admin user or something when we have the session of the beacon. In theory, yes, but this is depend of the session that we have in the command and control. For example, if we, in the example that I show with the meterpreter, if we try to do a hash dump or something like that, probably the EDR kill the process because it's very has a very bad obsess, exactly suspicious. But with another command and control or another techniques, it will be possible.
You can see, if you want to get more into that, there is a lot of info stealers that are moving to Golang because of these kind of things. So you can see how they do it. There's a ton of information in GitHub. Follow BX Underground, and you will not regret it.
Thank you.
Awesome. Thank you so much. Is there any other questions from the audience? I think we have time for just one. Yep, over here.
Hello.
Hello.
Knowing this about ADR, you think, XDR, you think a company should shift their defensive measure to network level? So you accept that CrowdStrike, it's missing the detection and it allows reverse shell. If you accept this, it's better to focus on network level protection and catch that outbound connection, let's say?
At the end, what an EDR company is doing is try to see malicious, suspicious, or something that is not related to end user. Okay, they are not God right now. They could be, but for example, Microsoft, what it looks something anomalous, and they need to find a way that match to something that is really malicious, is suspicious, because at least you are playing with a user. The one that is using the PC. If you have a blue screen of death, if you have a ton of things that could go wrong because right now the ADRs are moving to driver side, so a lot of things could go pretty wrong, CrowdStrike. You could see that what is going on, but they are in the right way for me. That this is the way. But how? Maybe you will see, okay, you don't upload this code to GitHub. It's 1 month ago uploaded. So we are doing this with the code uploaded, with everything uploaded. They have the telemetry, but maybe they don't have the time to implement it. That's different ways. They could detect it, but it's going to depend on the operator. If the operator is really bad and get a beacon and do shell who am I, he's born. If the operator runs Bloodhound without ask, he's born. So they need to follow a standard. At least for me, as an operator, it's more difficult than ever that you compromise a system and get domain admin and move into other things. But for example, to execute a malware is not as difficult. It's more to move into the network. And this is why the companies are focusing more in detect anomalous things and suspicious things in order to detect malicious activity, not only in the endpoint. There's more ways. And that's why they want to unify everything, like MDI of Microsoft, MDE. They have a ton of protections, and they have the data from another to the other, and they compare, and they mix all the data, and they say, okay, that's malicious, or that's not. But they are moving into flags. If they don't have a flag that say, okay, that's critical for me, they are going to allow it.
Yes, and the good point with the repository is that you have the option to craft your own malware. So you need to do manually. So this is a good point because it's more difficult to detect it, and you can combine techniques and everything. It's not something automatically. So that helps.